Good morning. This lesson is for my integrated 1 classes, but before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this lesson, but I'm going to title it how I title it in the title. But what I am sure of are 2 goals for the day. Our first goal is going to be to create the final version of our formula to represent tables of linear patterns. Our second goal is to work through examples of how to simplify the formula using the 6 steps to solve. Alright, I want to read through this so I don't repeat myself. We have the following formula that we have created for tables that have consecutive x values and constant change in y values. Here's our formula. Before I read this formula, remember we've gone through a process of creating this. And I believe this might be the 5th lesson or the 6th lesson, I don't know. But hopefully you've watched the previous lessons and seen how we've gotten to this formula, which is f of x equals the first y value plus the change in y values times parentheses x plus the opposite of the first x value. Now, the next variation of how the table can be presented will be non-consecutive x values. So that's the final thing that I can do to the table, and we'll create an equation for this, okay? So we'll create, I'll say repeating myself, we will create an equation for a table with consecutive x values. Next, we will erase a few rows and figure out how to recreate the same equation. So we're going to write an equation for this table that has consecutive x values and has a constant change in y values. So my y values are changing by subtracting 3. So this is what constant change in y values looks like. So now that I have a table, or now that I know that I have a table with consecutive x values and a constant change in y values, I can use our formula. And so the formula that would represent this table, the formula will represent the table with this linear pattern. Remember this, if I was to graph this, this would be a pattern of a line. Using our formula, we would get the following equation. F of x equals my first y value, which is 22, minus my change in y, which is 3, parentheses, x plus the opposite of my first x value. So the opposite of 5 is negative 5. And this is the equation that represents this table. Now remember, I want to write the same equation for this exact table, but I'm going to get rid of a few rows. And so what we're going to try and do is try to figure out how we get those numbers to be the same. Because if I write an equation for the same table, I should get the same equation. They should be the same, right? So let's write that out. The equation for a table, for the same table, should be the same. Okay, so let me modify this table so we have non-consecutive x values. And so our table now is going to look like this. We'll go 522 and we'll jump to 813. Okay, 522 and 813. So let's use what we have and let's see if we can make it match our equation that it should be. Because again, these are technically the same table, so they should have the same equation, right? The equation for the same table should be the same, right? Okay, so let's use what we know. Use what we got and figure out how to fix. Spell. Oh. Steve Gloria is back. All right, so here we go. So my change in y is now 22 turns into 13 by subtracting 9. So our equation that we're going to have is going to be f of x equals my first y value, which is 22, minus my change in y. It's the constant change in y because it's the only change in y. Parentheses x plus the opposite of the first x. So x minus 5. Now, I'm hoping that you recognize that the change in y is the number that's different. But remember, these equations need to be the same because these tables are technically the same. So we got to figure out how we can make a negative 9 turn into a negative 3, and a way that we would do that is to divide it by positive 3. And so now we have to figure out where in our table do we have a positive 3, right? So let me write that down. All right, so where do we have 3 in the table? I don't have a 3 here, I don't have a 3 here, I don't have a 3 here, and I don't have a 3 here. But there is a 3, and here it is. I have to now introduce the change in x. So what our formula is now going to become is it's going to now become f of x equals the first y value plus the change in y value divided by the change in x value, parentheses x plus the opposite of the first x value. So let's write out our new and final formula, right? So it's f of x equals the first y value, I hope I finish before the guy gets close, plus the change in y values divided by now the change in x values, parentheses x plus the opposite of the first x value. And so remember, again, I'm going to say this. These equations need to be the same because they represent the same tables, okay? So let's plug in what we got and we'll see that we get the same thing. My first y value is 22. F of x equals 22 plus my change in y values. So it's a minus 9 over my change in x values, which is a plus 3. Parentheses, x plus the opposite of my first x value, which is minus 5. And 3 goes into negative 9, negative 3 times. So our simplified equation, I really hope I'm going to fit on here. Not our simplified equation, our fraction that simplifies, f of x equals 22 minus 3, parentheses, x minus 5. Let me make sure I stayed on there. I hate having to re-record these things. Oh, I stayed on there just barely. Okay. So this is our new formula. Okay, and this is going to be the one that we're going to be working with, and I'm going to come back and show you how to simplify this formula using the 6 steps, because what can go wrong is the fraction doesn't go away. So let me clean all this up, and I'll be back. I'm back. So let's go ahead and continue with our second goal, and that's examples of how to simplify the formula using the 6 steps to solve. Now I wrote down most of the 6 steps. Step 1, eliminating fractions by multiplying everyone by the denominator. Step 2, distribute. Step 3, combine like terms on each side of the equal sign. We don't need step 4 and step 5. And step 6, divide away a number from the variable side of the equal sign. So these are the steps that we're going to use in conjunction with our formula to write and simplify the equation when we know 2 points. Now, let me just add this one little fact. When you simplify the equation, you're putting it into slope-intercept form. So when I give you directions like this, write the equation of the line in slope-intercept form passing through the points, I'm literally just saying plug in and simplify. That's the directions. Plug in and simplify using these steps, and we will have written the equation of the line passing through 2 points in slope-intercept form. So let's go ahead and do this problem. The first thing you're going to want to do is you're going to want to make a table. And we're gonna really lean on making a table for this chapter because that will help us really organize the material in such a way that we can simply make all the problems the same. All right, so here we have -2 going to 2. That means that I have a change in x of +4. And I go from 5 to -3 by owing 8. So I have my first y value, my change in y, my change in x, and my first x value. So now I can use my formula, which is f of x equals the first y value, which is 5, plus my change in y divided by my change in x, so it's -8 over 4, parentheses, x plus the opposite of the first x value. My first x value is -2, so the opposite of that is +2. Alright, so now this is us using our new modified formula. Now in this example, this will reduce. So we can actually write this as f of x equals to 5 minus 2, parentheses x plus. Alright, so now we can go through the steps and simplify the equation or put it in slope-intercept form. So we have our 6 steps, and we're not doing step 4 or step 5. Step 1, do I have a fraction to eliminate? No, I do not. Step 2, can I distribute? Yes, we can. So I can distribute the -2 to the x and the -2 to the 2, and I get now f of x equals 5. -2 and x gets me -2x. -2 and 2 gets me to +4. All right, can I combine like terms on this problem? Yes, I can. I can combine the 5 and the 4, and I get f of x equals to -2x. 5 and 4 give me to +9. And I don't need to divide anyone away because that's by itself. So this is the equation in slope-intercept form, which is in our simplified form. I'll explain later what slope-intercept form means, but right now I need us to know how to simplify it or put it in that form. All right, so that's one example. Next example is probably going to be the most difficult problem that I can offer this semester, and you'll see why, but to be honest, we have the skill set to do the problem. So let's make a table out of this. So my x and my f of x, and I have a 6, and I have a 2, and I have a 1, and I have a 7. You know what, I'm going to change this problem. I just realized something here real quick. I'm going to make this a 1 and a 4. Let's do that, 1 and a 4. Okay, you'll see why I had to do that here in a second. Okay, so a 6 turns into a 1 by subtracting 5, and a 2 turns into a 4 by adding 2. Okay, so now we can now plug in our numbers. I got my first y, my change in y, my change in x, and my first x. So we can have the following equation. F of x equals my first y value, which is 2, plus my change in y over my change in x, parentheses, x plus the opposite of my first x, which is -6. So I'm going to now write my 6 steps. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. All right. So before I continue, this is one number, this is one number, and all of this is one number. This is one number. Okay? So I do have fractions that I need to eliminate, and I need to eliminate that -5. So again, like I've done before, is I'm going to multiply everybody by the denominator. So this will be multiplied by -5, this will be multiplied by -5, and that will be multiplied by -5. Now I can go through and simplify what I have. And what we're going to do is we're going to eliminate the fraction, combine, bring the fraction back. Alright, so negative 5 and f of x gives me negative 5 f of x's. 2 times negative 5 gives me a negative 10. This negative 5 and that negative 5 cancel out, so I get plus 2, parentheses, x minus 6. Alright, so now I can distribute, because I have parentheses, right? Distribute the positive 2, the x, and the 6, so now I get negative 5 f of x's equals negative 10 plus 2x. 2 times negative 6 is minus 12. Let me make that look like an x. There we go. Alright, let's combine like terms here. So I get negative 5 f of x's equals minus 10. Minus 10 equals positive 2x. I owe you 10, I owe you 12, so I owe you 22. So now we can do the last step because my f of x is not by itself, where in this problem it was by itself. So we are going to now divide away the fraction. Alright, or divide away the negative 5. So we're going to bring back the fraction that we got rid of. And our simplified equation in slope-intercept form is f of x equals 2 over negative 5x minus 22 over negative 5. Now you could also make this a plus 22 because I have a negative and a negative. And you know, you could have also, let me add this in. You could have also put the negative up with the 2 and multiplied everyone by a negative or by a positive 5, and we would have still gotten the result. So this is an example of the two most difficult types of problems that we will have this semester. We're combining two ideas. We're combining our equation formula that we created, and we're combining the 6 steps that we had from earlier in the year. So I'm going to go ahead and end this lesson here. Again, I hope that this helps us with these problems. I might have to make another video or two just to reassert what we're doing here. So again, remember, it's the steps that we're already familiar with applied to this. So practice will help. And again, I'm going to go ahead and end this one here. I hope everyone is doing all right out there. Have a great day, everybody. Bye-bye.